Students, this is Math 3 Unit 4. This is Lesson 6, but if you're one of my students in fall 2020, this is Lesson 264, 2.6.4. We are in the last week of the second 6 weeks, and we're on the fourth lesson on Thursday. So yesterday we did some problems that look kind of like this one that's shown here, and we solved them by setting up a rational expression equation. We also found a lowest common denominator for all three terms. I'm going to show you a different way to do this today using the lowest common denominator for only the terms that are on the left of the equation. So let me show you what I'm talking about. Let me just point out a couple of key things here. So Matthew can finish a paper route in 5 hours. So Matthew finishes it in 5 hours. Jill finishes the same paper route in 3 hours. And then they ask, if they work together, how long will it take? And you know, when you see how long or how many or whatever, that's your unknown. So they want to know how long would it take them to complete the paper route together. So what we would do is we would call Matthew, let's say we call Matthew M. And the way we set this up is not like a 5x or a 5n, because it's not 5 times something. It's how long it takes him to finish the same job that it's taking Jill, a different amount of time to complete. So the way we set that up is with a ratio or a fraction. So what we say is Matthew can finish the one job in 5 hours. So it takes 5 hours for Matthew to finish this job. Jill can finish the same job, and we'll call her J, can finish the same job in 3 hours. So the same job in 3 hours. So if we put the hours on the bottom and the 1 on the top, because it's one complete job, that's basically how we look at this. And then they're asking together how long would it take them. So then the same job, and we'll put a T for together, the same one job would take them how long? So this is where our X goes. So then we set this up. I'll just change to a black pen here. We set this up as Matthew plus Jill equals the together. That makes sense. That means 1/5 plus 1/3 equals the time that it takes them together. So yesterday what we did was we looked at the 5, 3, and the X, and we came up with an LCD, or a lowest common denominator, least common multiple, whatever you want to call it, for all three numbers. What you could do is you could look at just this part and find a least common denominator for 5 and 3. Well, when you find a least common denominator for 5 and 3, you really just multiply them together. So the LCM or the LCD would be 15. And I didn't explain this in great detail yesterday because I was trying to make it look like the addition and subtraction problems that we had done. But let's talk about this. If I want to change 1/5 to something over 15, 1/5 equals what over 15? Well, what do I have to do to 5 to get 15? I have to multiply it times 3. Well, that means I have to multiply times 3 in the numerator as well. So that's going to be 3/15. So then I'm going to rewrite this 1/5 as 3/15. What do I have to do to 1/3 to get something 15? So I have to multiply times 5. We remember from our addition and subtraction of rational equations, or rational expressions, excuse me, that if we multiply by something in the denominator, we have to do the same thing in the numerator. So that would be 5/15. So 1/3 equals 5/15. So I'm going to rewrite that as 5/15. So all I'm doing is rewriting these two equations, these two expressions, two fractions, as equivalent fractions. I'm going to leave this 1 over x this time. Yesterday we changed all of them to 15x, but I'm going to do it a little bit differently today because I want to show you something else, another way to solve these. Now I can add the 3/15 plus the 5/15. That would be 8/15. You just add the numerators. So 8/15 equals 1 over x. Now, you might remember back from elementary school solving proportions. And the easiest way to solve an equation like this with two fractions is to use what we call cross products. Cross products are where we multiply across. We multiply the 8 times the x, and we multiply the 15 times the 1. So if we multiply across, and I draw it usually, make an x in there. If we multiply across, we multiply 8 times x, that's 8x, equals 15 times 1. So 8x equals 15, divide by 8, and let me grab my calculator because I don't know what this decimal number is going to be. That's going to be 1.875. X equals 1.875. And this was hours. So this is another way that you can solve this type of problem. Just find the LCD for both of the fractions on this side. Just add them together and then use cross products to solve the equation. I don't know which way you would prefer, but the reason I'm showing you this today is that we are going to be using cross products to solve the equations that we set up today. They're a little bit different than the ones we did yesterday. Let's just try one more with just the fractions. Okay, so let's say Paul can build a birdhouse. I don't know. Paul can build a birdhouse in 10 hours. So 1 over 10, that's Paul. And then Lynn can build the same birdhouse in, let's say, 8 hours. So he would be 1 over 8. How long would it take them to build that birdhouse together? So there's my equation. Now, 10 and 8 have a least common multiple, lowest common multiple of 40. So I could multiply the 10 times 8. That would work. But I can also use 40. It's just a smaller number that I can use that both of them do divide into. Okay, so 1/10 equals how many 40ths? Well, 10 times 4 is 40, and 1 times 4 is 4. So I'm going to change the 1/10 to 4 40ths plus 1/8. And, you can probably do this in your head. 8 goes into 45 times. 5 times 1 is 5. That equals how many 40ths? That's times 5 times 5. So this changes to 5 40ths. You still got your 1 over x, okay? 4 40ths plus 5 40ths, that's 9 40ths. So at this point, I have one of those proportions that we did way back in like 7th grade, I think. I think that's when we do those. And we can solve using cross products. 9 times x equals 40 times 1, which is 40. Divide by 9, and you'll get your, let me see what that is. You might also remember doing this without even writing the 9x in the 40 part. 4.44. X equals 4.44. So what you might remember too is that when you had a problem like this, and this is what I would teach my 7th graders as well. If you had something like this, the cross products where you have both numbers, you multiply those two. And then you divide by this number. So 40 times 1 divided by 9. So, and that's an even faster way to do this type of problem. All right, so that's just another way to work this type of problem. Just wanted to just kind of remind you of the cross products rule, where you can use cross products to solve an equation that has fractions on both sides, or even that has a fraction on one side. All right, so let's look at our problems. These are a little bit more difficult. Just bear with me here and just try to follow. I'm going to go as slow as I can and try to explain how this works, and then we'll speed it up a little bit. Okay, so the speed of the stream. All right, I want you to think about this. If you've ever been in a boat, the speed of the stream matters. It also matters whether you're going upstream or downstream. If you're going upstream, you are fighting that 6-mile-an-hour current, right? If you're going downstream, it's helping you. You're going 6 miles faster an hour than you would if it was just still water. What we're looking for is the speed of the boat. I'm going to use some highlighters and just highlight some things that we're looking for. What is the speed of the boat in still water? So that's what we're looking for. What is the speed of the boat if the water is not moving? Okay, so the speed of the stream is 6 miles an hour. So let's think about this a minute. Let me grab a pen. So if I'm going upstream, Upstream means I'm going against the current. Then whatever speed I'm going, I'm fighting that 6 mile an hour. So what I would need to do, if my speed in still water is X, okay? So speed in still water, we're going to call that X because that's what we're looking for. Then my speed going upstream would have to be X minus that 6 miles an hour, okay? If I'm going downstream, I'm going with the current. It's kind of like when they talk about the wind at your back. you're going with the current. And if you're like in a sailboat, it's like the wind is pushing you, okay? So if I'm going downstream, then what I would do is I would take that speed and I would have to add 6 miles an hour to the speed of the stream, right? Because it's helping me. Okay, so let's look at some more of this problem. Okay, so I'm just going to do some different colors here. What matches the downstream speed? So, well, no, let me look at the upstream. I'm sorry. Upstream speed is X minus 6, okay? The boat it travels 47 miles upstream, okay? So let's say, like 47 miles would be kind of the matching item for this number right here, okay? So it travels 47 miles and it's going X minus 6 miles an hour. And we don't know what X is. We just know that it's fighting the current in that case. So that matches the upstream speed. So we could kind of say that X minus 6 matches 47. Now, X minus 6 doesn't equal 47. We can't figure it out that way. But we're going to set up a proportion here. The 94 miles, this one right here, matches the downstream speed. So the 94 miles is going to go right here. So what I'm going to do is I'm going to set up a proportion where this number over this number, 47 over X minus 6 equals 94 over X plus 6. So it's a proportion where you have the miles traveled, in the numerator, and you have the speed going upstream and downstream, the speed of the boat in the denominator. Well, now what we can do is we can actually do we've set up a proportion, so we can use cross products to solve it. So let's look at this. 47 times X plus 6. I'm just going to write it like this, and I'll use distributive property in a minute, equals 94 times X minus 6. Okay, so let's just solve. We're solving for X. First thing we have to do when we solve for X is we have to get rid of these parentheses. So I have to distribute the numbers into the parentheses. So 47 times X is 47X plus, what is 47 times 6? Let's see. 282, it looks like. I'm going to check that. That's what my key says. 47 times 6, 282. Okay. And then I'm going to distribute the 94 over here. 94x minus 564. Make sure. 94 times 6. Okay, and that's minus. So now let's solve for x. I think what I will do is I'm going to subtract 47x from both sides, and I'm going to add 564 to both sides. Okay, so that cancels right there. That cancels right there. I have 564 plus 282 is 846. And 94, oh, that should be a minus, I'm sorry. Minus 47 is 47. Let me make sure. Okay. Let's rewrite this over here. 47x equals 846. Okay, divide by 47. I think x equals 18 miles per hour. So the speed of the boat in still water is 18 miles an hour. If it had asked you what is the speed of the boat going upstream, that would be 18 minus 6. And then the speed of the boat going downstream would be 18 plus 6. Okay, so that was really slow going through that. I'm going to try to go a little bit faster on some of the subsequent problems. But I just wanted to kind of point out this is how this is set up. I just be patient with it and really look at the different parts that you've been given and figure out what matches what. Okay. All right, let's look at another one, number 2. So a loaded moving truck is traveling 20 miles per hour faster than a freight train. In the time it takes for the train to travel 160 miles, the truck travels 240 miles. Find the speed of the truck. These are those types of problems that you see like on social media, and they're like, no way I will ever be able to solve this. You got this though. You can do this. Let's look at our different parts here. Let's talk about what the two different, let's talk about the truck and the train. Let me highlight these. Okay, so the moving truck, 20 miles faster than the freight train. Okay, so let's start with that. So let's say that the freight train, I'm going to abbreviate that. Be easier. Freight train. The speed of the freight train is, just call it X, okay? And then the speed of the moving truck would be X plus 20, because the moving truck is moving 20 miles per hour faster than the freight train. So I'm going to call the freight train speed X, the moving truck speed X plus 20. So this is the speed, okay? What I'm looking for is the speed of the truck, all right? But what I have to use too is the number of miles that they went. So let's see. What matches the freight train's speed? The number of miles that it traveled was 160. So that matches that one. What matches the moving truck's speed? It traveled, not matches, but what would go with it in a proportion. It traveled 240 miles. Okay? So that means 160 would go here, 240 would go here. I'm going to put 160 over X and 240 over X plus 20. And then I'll solve using cross products. 240 times X is 240X. 160 times X plus 20, I'm going to write it over here. And then I'm going to do distributive property and put that here. 160X plus, that is going to be, I believe, 3,200. Okay, now how do I solve for X? I'm going to subtract 160X from both sides. That cancels right there. I have 3,200 over here. And on this side, let me see, 90. Yeah. Is that 90? It's not 90. I'm looking at the wrong problem. Sorry, my problems are so small on here. I can barely see them. It's 80x. Oops, 80x. Divide by 80. Those two cancel. 320 divided by 8 is 40. All right, now, x is 40. What did it tell me to find? Find the speed of the truck. The speed of the truck is x plus 20. So the speed of the freight train, 40 miles an hour. The speed of the moving truck, though, is 40 plus 20, so it's 60 miles an hour. Watch what you're asked for. So that would be our answer that we're looking for right there. Okay, we've only done 2 and we're 19 minutes in, but we're going to do as many as we can, and then I'm going to do some more during the live lesson or during the live meeting today. All right, let's see what we've got here. Brad and Kristen agree to meet in Chicago. Brad travels 104 miles in the same time that Kristen travels 96 miles. If Brad's rate of travel is 4 miles more than Kristen's, at what speed does Brad travel? Well, let's think about this. Brad's rate of travel is 4 more than Kristen's. So a couple of different ways we could write this. We could call Brad's speed X, or we can call Kristen's speed X. It really doesn't matter, but it would matter whether you did like X minus 4 or X plus 4. So just be careful with that. His is 4 more than hers. So we're going to call Kristen's rate of speed X. So this is speed. And then his is 4 more than that. So Brad's rate of speed would be X plus 4. What goes with Kristen's rate of speed? Kristen travels 96 miles. Okay. So the 96 goes with hers. And this is the number of miles. So it's kind of like a little, it's like a little chart that we're setting up here. And then Brad travels 104 miles. Now, it honestly doesn't matter whether you put the X's on top or the numbers on top. I just always put the numbers on top, but it doesn't matter which one you put on top because your proportion will end up the same. So I'll just show you. You could do X over 96 equals X plus 4 over 104. Or you could do 96 over X equals 104 over X plus 4. You just don't want to switch one of these. They have to just be, you have to have speed in one place, and then like here's speed, and then you have to have the miles in the other place. You can't have miles over speed over here and then speed over miles over here. It won't work. Okay, so let's do the left side. Let's just I'm marking this out. It's not wrong, it's right, but I'm just marking it out. Okay, so let's do this one over here. X times 104 is 104x. 96 times x plus 4. That's going to be 96x plus, what is 96 times 4? $384. Okay, so I'm going to subtract 96x. That cancels. 104 minus 96x is 8x. Equals 384 divided by 8. X equals, what did we get? 48. Okay. That's Kristen's speed. What are they asking us? They're asking us for Brad's speed. Okay, so this is Kristen's speed. Hers is X. It might have been a better idea for us to call Brad's speed X and then call Kristen's X minus 4. Doesn't matter, we still would have gotten the same answer. Brad's is 4 more than that. So Brad's is 52. So this is our answer right here. Okay, here we go. Number 4. Boat goes 450 miles downstream. Same time it can go upstream at 360 miles. So we got two different speeds. We've got 450 miles, and this is downstream. That's not how I want to do that. $450 miles. And we have 360 miles. Okay. The speed of the current is 8 miles an hour. So remember, downstream, it's going to add to the 8. The 8 miles an hour is going to be added to it. It's going to be x plus 8. And then upstream, the 8 miles an hour is going to be subtracted from it because it's fighting that current. So 360 would have x minus 8 with that. So 450 over x plus 8 equals 360 over x minus 8. 450 times x minus 8 is going to be 450x minus, it's going to be a big number. Let me grab my key. I can't even see my key. It's printed so small. So this is 3,600 equals, that's going to be 360x plus 2880. These are big numbers, but you're still solving an equation like you always do. I'm going, well, where's my pen? I'm going to subtract 360x. Gets rid of it there. Okay. And then I'm going to add 3,600. Gets rid of that. All right. This is 90x. And let's see, 2880 plus 3600, 6480. Let's divide by 90. See what we get. 72. X equals 72. So the speed of the boat in still water would be 72 miles per hour. Plane, this is not the same on yours because I typed these myself and I didn't really look to see what I was typing, so it's misspelled up here. And it's supposed to say a plane flies, not a plan flies. Anyway, a plane flies 450 miles with the wind, okay? 300 miles against the wind. The wind speed is 29 miles an hour, okay? So let's look at what we have here. So if the plane flies with the wind 450 miles, that would be X plus 29, because it's kind of like traveling with, or with the current, okay, downstream. If it flies against, it can only go 300 miles, and it's going, because it's going X minus 29 miles an hour, whatever that is. And we're looking for the speed of the plane, which is our X here. So let's see, let me get a better pen here. 450 over X plus 29 equals 300 over X minus 29. I'm not going to take all the time to solve this. We know how to solve this. It's distributive property, and we get, variables and constants on both sides. I'm going to give you the answer to this if I can see it on my key. Let's see, 145. X equals 145 miles per hour. So I'm just going to give you the answer to that one. It's honestly more important that you know how to set these up because you know how to solve equations. So let's look at another one and see if you can figure out, oh, this one's different. Never mind. Okay, so these are different types of problems. These are like algebraic problems. Okay, the first time I read this one, I actually set it up wrong in my head. So let me see if I can get this right. If you see a number, okay, that's X, right? And then minus 12 times its reciprocal. Okay. So this right here all kind of goes together. Its reciprocal, the reciprocal of X is 1 over X. But 12 times that is going to be 12 over X, because think about it, 1 over X times 12 over 1 is 12 over X. Okay. This is X over 1. So X over 1 minus 12 over X equals 1. That's my equation. X over 1 minus 12 over X equals 1. So what I can do is take the left side of this equation. That's what I would prefer to do, is I would prefer to take this part and make it have a common denominator. Well, a common denominator is X, 1X or X, okay? Well, the 12 over X already has the X as a denominator. I need the X over here as a denominator. I keep circling these because I'm used to that PDF where y'all can't see what I'm pointing to, but I know you can see this. So to get X over here, I have to multiply times X over X. All right, so what that gives me on this left side right here is X squared over X minus 12 over X equals, let's just change this to the same thing, because that's really the only way we're going to be able to solve this. 1 equals X over X. Now, my denominators are all the same. I can mark them out. X squared minus 12 equals X. Okay, so this problem is going to have two solutions. I need to get 0 over here on the right side. To do that, I need to subtract X on both sides. Well, there's no like terms for X over here, so I'm going to rewrite X squared minus X minus 12 equals 0. Now I can factor this part, okay? And I can find the two answers that would work. So let's see, X squared minus X minus 12. I have a negative 12, and this is a 1, a negative 1. I know I'm going to use 4 and 3. I need to get -1, -4, plus 3 is -1. So my factors are x minus 4 and x plus 3 equals 0. Set up each of these equal to 0. X minus 4 equals 0, so x can equal 4. X plus 3 equals 0, so x could equal -3. Either one of these answers should work if you plug it in to the original problem. And I'm not going to go through that, but if you take, let's see, 4, okay, actually, okay, a number, 4, minus 12 times 1/4. What is 12 times 1/4? Is 3. 4 minus 3 equals 1, and it would work with 3 also. Okay, we got another one like that. The sum of a number and 3 times its reciprocal is -4. Let me look at this one real quick. So yeah, this one's also going to have 2 solutions. And I know I'm at about 30 minutes. I'm going to try to do maybe one more after this one. That's one of the upstream, downstream ones again. Okay, so let's see. A number, this is x. And is plus. 3 times its reciprocal, so this is the next part. 3 times 1 over x is 3 over x. And we'll put the -4 over 1. So there's my equation right there. I need x to be in all of these, okay? So multiply that. This one doesn't need it because it's already got x. And we'll do that one. Okay, so I have x squared plus, x squared over x plus 3 over x equals -4x over x. Denominators are all the same. Forget about them. X squared plus 3 equals -4x. This one solved exactly the same way the one while ago was. Whoops. Trying to move this up. There we go. I'm going to add 4x over here. X squared plus 4x plus 3 equals 0. Factor this part right here. This is going to be x plus 3. X plus 1 equals 0. X equals -3. I'm not going to set it up equal to 0. We know it's the opposite. X equals -1. And I want to do one more. I think we've got like 2 or 3 more. I'm not going to do number 8. I will do number 8 in the live meeting today. So don't mark this out. You still need to do it. Come to the live meeting and I'll do it there. Number 9. Okay, I think this would be a good one. Yep. And this is the last one we'll do, and I'll do number 10 in the live meeting also. Okay. Julia takes 15 minutes. Julia is 1 over 15. Jake is 1 over 60. Oh, that's Jake, and that's Julia. And then how long does it take for both of them? Both, or together, is 1 over x. Okay, 1/15 plus 1/60 equals 1 over x. I like solving these with cross products, so that's what I'm going to do. My LCD is 60. So I'm only going to do the LCD for this part of the equation. I'm not going to do it for this part over here, just because that's just what I prefer. I don't care how you do it. Okay, so my LCD is 60. This one already has the 60, so I don't have to do anything to it. This one I need to change. I need to change 1/15 to something over 60. Well, 15 times 4 is 60. So this fraction is going to change to 4/60. This fraction stays the same. And then this fraction, I just bring it down also. 4/60 plus 1/60 is 5/60 equals 1 over x. Multiply 6 times 1, 60. 60 times 1, sorry, is 60. And then divide by 5, and that'll give you what x is. 60 divided by 5 is going to be 12, I believe. If I can see my... Yes, that's right. So it is, was it minutes? Minutes. Okay, so number 10 we'll do in the live lesson, and number 8 we'll do in the live lesson.